Hello. Welcome to physics. Today we are discussed about the projectile motions. Projectile motion is a most fundamental topic of physics and also for JEE exam and NEET exam. Here we are discussed about some basic problems, some basic numerical problem and the basic concept of the projectile motion. Projectile motion is a 2D motions, and in projectile motions both coordinate mean x and y, both coordinate of the particle of the object continue change with respect to time, as like the motion of cricket ball in stadium in ground, mean motion of the ball, and in the situations both coordinate change with respect to time as like this. Topic for discussing. Topic projectile motion, right? And projectile motion is a 2D motions. 2D motions mean x and y both coordinate change with respect to time in 2-dimension motions. And suppose that this is a coordinate systems and this is a x axis and this is a y axis. And suppose that this is a cricketer, mean player, and throw ball as like this. This is a ball and ball throw as like this, right? In the situations velocity of the ball u, and u is a known as a projectile velocity, and here coordinate of the object, suppose that here coordinate of object x and y mean x1 y1 and here x2 y2, right, and here x3 y3 and here x4 y4, mean x and y both coordinate change with respect to time. This is an example of projectile motions, and velocity also change because here y coordinate change mean vertical directions, mean vertical component of projectile velocity change with respect to time. Initially we are discussed about the flight of time, range and height of projections, right, mean flight of time, height and range of projections. Suppose that this is a y axis and this is a x axis. Ball throw as like this is a projectile path, and projectile velocity, this is a projectile velocity u, and this is a projectile angle with respect to horizontal, and here divided both component mean horizontal and vertical component of the projectile velocity mean ux equal to u cos theta and uy equal to u sin theta. For your knowledge, horizontal component of the projectile velocity remain constant, and vertical component of projectile velocity change, and at a peak point this value becomes equal to 0 and particle move along this direction ux equal to vx, right, and equal to u cos theta. Initially we are calculate flight of time. What is the concept of flight of time? What is the logic of flight of time? Flight of time of the object mean time taken by object during projectile motions, during complete projectile motions, ball throw at this point and time taken for this journey, right, known as a flight of time. This is a flight of time, and calculate flight of time. For the flight of time, responsible vertical component of projectile velocity, flight of time. This is a component of projectile velocity, coordinate system as like this, and here ux equal to u cos theta and here uy equal to u sin theta, and this point mean at peak point vy equal to 0. Using first equation of motions, mean v equal to u plus at. For y directions mean vy equal to uy plus ayt, and put value here vy equal to 0 at a peak point mean vertical component of projectile velocity change due to gravity, but horizontal remain constant because gravity does not work along the horizontal direction, gravity work along the vertical directions. This is a region, and uy equal to u sin theta according to this component, right, u sin theta, and ay equal to negative g because accelerations due to gravity act vertical downward. Put here 0 equal to u sin theta minus gt mean t equal to u sin theta divided by g, and total flight of time t equal to 2t because this is a time for this journey, right, time for this journey, and this is a time known as a time of ascent, and time for this journey known as time of descent. Time of ascent equal to time of descent equal to t mean u sin theta divided by g. Total flight of time 2 u sin theta divided by g. This is a value of flight of time, flight of time. For next calculations, horizontal range and height of projections. For the height of projections, what is the logic? This is a height of projections, right? This is a height, and component of projectile velocity ux equal to u cos theta and uy equal to u sin theta, and this point vy becomes equal to 0. And for the height of projection responsible this velocity, responsible vertical component of projectile velocity. Calculate this derivation from third equation of motion, mean v square equal to u square plus 2gh, right, mean v square equal to u square plus 2as can be written as like this, mean s equal to h, a y equal to minus g, vy equal to 0 and uy equal to u sin theta as like this, and for the y directions vy square equal to uy square plus 2ayh, and put value here, given data put here, mean 0 square equal to u square sin square theta minus 2gh, mean h equal to u square sin square theta divided by 2g. This is a basic value of the height, right, basic value. This is a maximum height of projections, maximum height. For the next calculations, range, right, this is a range, this is a horizontal range, and for this range responsible ux mean horizontal component of projectile velocity, and here u sin theta, right. This is a distance, horizontal distance, and distance equal to velocity multiplied time and time t. For the calculation of range, mean r equal to ux multiply flight of time 2u sin theta divided by g. Calculate this value and put value of ux, mean u cos theta, mean u cos theta multiply 2u sin theta divided by g, right, and here range equal to u square multiply 2 sin theta cos theta divided by g. From the mathematical formula sin 2 theta equal to sin theta multiply cos theta, and put here, mean r equal to u square sin 2 theta divided by g. This is a range of projections, and for the maximum range, right, for maximum range r max, projectile angle must be equal to 45 degree, projectile angle must be equal to 45, mean theta equal to 45, and for the R max theta equal to 45 and double sin 90 equal to 1, mean u square divided by g. This is a maximum range of projections. This is a maximum range of projections, right? And one numerical problem related to this. Suppose that this is a coordinate system, x axis and y axis, and electric field, uniform electric field act like this, right? And this is a value of electric field, this is a value of electric field, and a negative charge uniformly distributed as like this, right? Negative charge. This is a uniform electric field and value of electric field vector E act vertical downward, and from point A, positive charge ball, right? Positive charge ball projected L like this. This is a target point, right? This is a target point. In the situations, calculate flight of time, calculate range and calculate height of projections according to given diagram, according to given problem, according to given situations, right? Solve this problem. Initially we calculate accelerations due to gravity and acceleration due to external electric field. This is a problem, projectile motions. Projectile motion in uniform electric field. Uniform electric field, right? Projectile motion in uniform electric field. Initially we calculate the accelerations due to gravity and acceleration due to external electric field. Acceleration due to gravity act vertical downward always, and acceleration due to external field force QE divided by QE. This is a force, mean electric force, and for the accelerations QE divided by m, because this is a positive charge and direction of electric field vertical downward. In the situations, direction of this accelerations also vertical downward. In the situations, acceleration due to gravity means G effective equal to G plus QE divided by m. This is a value of G effective, right? And now very simple calculation for this derivations, very simple, no any problem, no any difficulties here. Initially we calculate flight of time, and basic formula of the flight of time 2u sin theta divided by g, only g, but now using here g effective, not using only g, here using g effective, and put value of g effective here, t equal to 2u sin theta divided by g plus QE divided by m. This is a basic formula of the flight of time and most important result, most important concept for the calculations for your JEE exam and also your NEET exams, because basic formula of the flight of time 2u sin theta divided by g when no any external field applied during projectile motions, but when external field applied as like this, then accelerations due to external electric field vertical downward, gravity also vertical downward act, and using G effective, value of G effective calculate and put here. This is a formula of the flight of time of the charge ball. For the next calculations, height, of projections, height of projections, and height of projections, basic formula of the height of projections, u square sin square theta divided by 2g, but here using g effective, and value of g effective g plus QE divided by m. Put here mean value of height of projections u square sin square theta divided by 2g effective, right, and put value of g effective, gets value of height of projections sin square theta divided by 2 and bracket g plus QE divided by m. This is the most important logic for the projectile motions. And also now we are calculate the range of projections. Basic formula of the range mean ux multiply flight of time. This is a basic formula of the range, right? And according to given diagram, accelerations along the horizontal directions equal to 0, no any accelerations, and acceleration along the vertical directions equal to g effective, mean equal to g plus QE divided by m, and also put here, right. In the situations r equal to u is r equal to value of ux u cos theta multiply value of flight of time, mean 2u sin theta divided by g effective, and value of g effective g plus QE divided by m, and calculate this formula, mean r equal to u square sin 2 theta divided by g plus QE divided by m, right. This is a basic explanations of the projectile motion, very simple, no any difficulties here for the calculation of the numerical problem related to any topics, as like projectile motion, as like the circular motion, as like NLM, no any difficulties. If your concept very clear, then no any problem for the calculations of the numerical problem, JEE exam and also your NEET exams, right. For the next calculations, this is a x and this is a y axis, and particle project as like this, right, and after some time coordinate of the object becomes x and y, right. This is a x and this is a y. If we want to calculate the coordination of x and y, how to calculate, how to manage, how to solve this coordinate, right. Solve this problem. Projectile velocity u, and here u cos theta mean horizontal, and here u sin theta mean vertical component of projectile velocity. According to previous knowledge, mean acceleration along the horizontal direction equal to 0, acceleration along the vertical direction negative g, velocity at a peak point equal to 0, and other parameters same as a usual concept. Want to calculate x and y coordinate. For the x coordinate using second equation of motion, second mean s equal to ut plus 1 by 2 at square. For x directions, x equal to uxt plus 1 by 2 ax multiply t square, and using here parameter mean x equal to u cos theta multiply t, and ax equal to 0, and this is a becomes total 0, and coordinate x equal to u cos theta multiply t mean t equal to x divided by u cos theta. This is a value of time at this moment, right. And for the y coordinate, for the y coordinate, for y coordinate, using second equation of motion for y coordinate, second equation of motion mean s equal to ut plus 1 by 2 at square. Convert along the y directions mean y equal to uyt plus 1 by 2 ay t square, and put value here mean y equal to u sin theta, and value of t mean x divided by u cos theta plus 1 by 2. Value of accelerations along the vertical directions mean minus g, and t mean x divided by u cos theta, right, square, and calculate this value. This equations mean u and u cancel out here, mean x multiply tan theta minus gx square divided by 2u square cos square theta. This is a value of y coordinate of the object during projectile motions, right. And for the most concept, most important logic, relation between x, y and r. What is the relation, right? What is the relation between x, y and r? Mean both coordinate, both mean all coordinate. What is the basic relations? Using some concept from these equations, mean y equal to x, and using here trigonometry function means sin theta divided by cos theta minus gx square divided by 2u square cos square theta. And for the next step, x divided by cos theta is a common factor from whole equations, and 1 by cos theta 1 sin theta minus gx divided by 2u square cos theta, right. And for next step, y equal to x divided by cos theta sin theta minus x divided by 2u square cos theta divided by g, right. And now using the equation of range of the object during projectile motion, mean equation of range r equal to u square, right, sin 2 theta divided by g, and using trigonometry formula mean u square multiply 2 sin theta cos theta divided by g, and here r divided by sin theta equal to 2u square cos theta divided by g, and this value put here, mean value of 2u square cos theta divided by d equal to r divided by sin theta, mean y equal to x divided by cos theta bracket multiply sin theta minus x divided by, right, x divided by r divided by sin theta, and from this formula x multiply tan theta 1 minus x divided by r, right. This is a most important relation between y, x and r, right. This is a basic lecture about the projectile motion, and also most important concept, most important logical concept for the JEE exam and also NEET exam. Thank you.